Today we are going to talk about well site operations and mud logging. Um, my name is Muhammad Al-Fatih. I am a petroleum geologist. I worked in different entities and companies. At first, I worked for China National Logging Corporation in the mud logging department for 3 years. That led me to join Ministry of Energy and Petroleum in Sudan, um, where I have been working till now for nearly 7 years. Um, in 2022, I joined 2B OPCO, which is a Sudanese operating company, on the job training program in the exploration department, day-to-day activity. Um, in 2023, I joined Bicep Fran Lab, um, mainly in petroleum system and basin modeling, petroleum system analysis. Um, okay. Mm, as introduction, uh, we'll talk about drilling rig uh, types and drilling rig system. This is our agenda. Also, the main operations in well site, and we'll focus on mud logging particularly. And this is an introduction for the upcoming course about well site operations and mud logging. Um, for further information, you can contact Skill Up. Okay, as introduction for drilling rig types, you can find different classification, for example, offshore rigs and onshore rigs, but that doesn't make sense. The main idea is the operating environment of each rig. For example, drilling ship, it operates at water depth up to 12,000 feet. For also submersible, it operates at water depth up to 10,000 feet. For jackup rig, water depth up to 500 feet. Drilling barge for shallow waters in the transition zone, and land rig. We'll focus mainly on the land rigs. The main components of drilling rig, for example, this is the crown block, it's monkey board, also known as the Drake board. This is a mast. This is a traveling block. This is a crown block and traveling block. This is a top drive system. Also, is on the rig floor. You have draw work, which is the most important element in the hoisting system, as we will see in the next slides. Um, it's a blowout preventer, the flow line. This part is also related to well control um, system. It's known as mud gas separator or bore buoy. Here you can see solid control equipment consists of shell shaker, um, desander, degasser, and desilter, also centrifuge for removal of cuttings and solid contents. Also some mud tanks. Mud tanks consist of a mixing tank and a suction tank, and uh, go in depth in the course, inshallah, about each element of rig and the components and the function of each one. Also, this is a power system. Example is the gensets, this, compressors, which starts up the gensets or generator sets. Is a mud bits used to dump the mud and cuttings from shell shaker or desander, desilter. Those are offices of drilling supervisor, is a tool pusher, and just a rig engineer. Um, Inshallah, in the course, we will see real life images of each part of this rig. That's just this an overview. For the delivery systems, we start with a hoisting system, which consists of crown block and traveling block. And the most important part um, serves as the beating heart of hoisting system is the drawwork, is the rail line, is the hook attached to traveling block, is the swivel, and is the deadline anchor, which is very important, especially when we will talk about mud logging sensors and hook load and weight on bit parameters. Is the supply reel. The hoisting system serves as in lowering and lifting of the reel string. And the second system is a circulating system. It is very important for cleaning mud, as serves as mechanical treatment for the mud to reform mud to get the good of, conditions of the mud and the required properties of drill mud. Also, it is very important for Wellsite geologists and the mud logging because the quality of data of the mud logging, for example, the cutting sample and gas sampling, it depends on the efficiency of circulating system, especially the solid control equipment, which consists of shell shaker, which removes large, large size cuttings, degasser, removes the gases, desander and desilter. Sometimes you find the term of mud cleaners. It removes this sand size and silt size. Also mud tanks. Uh, for example, the mixing tanks used to prepare the mud, mixing the mud as per the required properties. Then the suction tank. Then rotary hose through swivel down inside the string, down the hole, then remove the cuttings through the annulus to the shell shaker. We'll talk about it in much details, inshallah, in the course of the. For example, this is a mud tank, and this is a mud pump. We will have some details about the types of mud pumps. The third system is the rotating system. Uh, Rotary table in Kelly system is a rotary table, master bushing, and Kelly bushing. Also top drive system, the T also known as TDS, is a top drive system. It's a huge motor used to uh, uh, rotate the drill string. Downhole motor, and especially in directional drilling, they use more advanced techniques in drilling and in the geosteering, as we will see, inshallah, in the course. Then the power system, which supplies required power for the rig components. Power system consists of generator sets. Sometimes you find the term CATs, which means Caterpillar engines, refers to manufacturers of the generators. Then the two units silicon control rectifier, which transform alternative current to direct current, because most of the components um, work with direct current, and the generators provides alternative current. Then the variable frequency driver, especially with the top drive system, because top drive system need controlled alternative current and control room. It's example of generators and silicon control rectifier. The fifth system is the well control system. Start from BOB stack, blowout preventer stack to prevent blowout, and accumulator unit, also known as COM unit, then gas separator or pour boil, and vacuum degasser, choke and kill manifolds. Also, we will go in details about the well control system and the most important parts of it, inshallah, in the course. Okay, about drilling fluid, it is a mixture of liquids and chemicals that allows drilling and completion of a well. This is the most simplified uh, definition. The functions of drilling fluids related to operations and related to formation and the geology. We'll go in much details, but we'll just see two types of drilling fluid, especially drilling mud, water-based mud and oil-based mud. For water-based mud, they may use fresh water or brine water to mix the chemicals. The advantage of water-based mud is cost effective because we use water, either it's fresh or brine, so it is less costly, and also it is easy to handle. But the disadvantage of water-based mud is shell sensitive, especially in area of reactive shale, which is react with operational problem, as you know, stuck problems, mechanical stuck, and that lead to more complication of operations. Then the oil-based mud, they used oil as a base of to mix the chemicals. The advantage of oil-based mud is non-reactive, inert. So they use oil-based mud in case of area of non-reactive shale, for example. But the disadvantage of oil-based mud is expensive, and also they have environmental impact. And related to the interpretation of mud logging and wireline logging, there will be some contamination and some difficulties in interpretation of oil shows, either in mud logging or in wireline logging. This is an example of the drilling fluid program. Each interval or section, the program indicates which type of mud is designed or needed to be designed. Also, the mud properties like density and funnel viscosity, yield point, plastic viscosity, ABI, and other properties. So this mud drilling fluid program comes in the drilling proposal, well drilling proposal. Health, safety, and environment is a very important part on the rig side because drilling operations is very risky. So before any start of any job on the rig side, they must have on the pre-job safety meeting and at first safety induction. Then prior to conduct of any operations, pre-job safety meeting must be conducted. This is an example of rig safety equipment, first aid kits in case of any injuries, fire extinguishers with different types, for example, carbon dioxide, powder, or foam. Also, emergency air supplies, for example, like self-contained greasing apparatus, which is very important in case of hydrogen sulfide. Also, warning sirens used to alert the personnel on the rig side of any hazards, for example, security issue or well control issue, kick or blowout. Also, if there is hydrogen sulfide, also smoke detectors on the each room and on the, uh, for example, mud logging unit, office, drilling supervisor, Wellsite geologist to detect any smoke. Wind indicators, also known as wind socks, indicate wind direction and also wind speed, especially in case of hydrogen sulfide gas, because it is fatal gas. Also, the master point and the location of these equipments should be noted prior any emergency. They conduct drills every time. Um, for example, evacuation drill uh, to train the personnel to evacuate in more effective way and um, in very short time. Um, For well planning is an interactive process between geosciences and engineering. It involves frequent access to several databases and clear communication between each parts. Um, there are three basic areas to be examined in the planning. Well, first, what targets will be evaluated, primary target and secondary targets. Then how will the well be drilled to reach those targets, including game plan, which includes drilling parameters, uh, drilling fluid properties, also the different sections of the well, intermediate section and um, manhole section, and so on. Also, how will the target zones be evaluated, including sampling program in the mud logging and wireline logging program in details. The data package at Wellsite, especially for Wellsite geologists, includes all the needed data for correlation and evaluation. For example, maps, offset wells, logs, and well prognosis to facilitate the process of evaluation and interpretation of samples and picking, for example, formation tops and sweet zone during drilling. This example of abbreviations of operations, they usually write uh, the operational report in abbreviations. This is some example of abbreviations. For example, R/U indicates rigging up, R/M indicates rigging down operation, RIH running hole, BWOH pull out of hole. For example, this is an open end drill pipe, wet on cement, and so on. You must be familiar with these abbreviations, uh, whatever your position on the rig side. For example, in operating company or in the surface company, you should know the abbreviations. Inshallah, we'll discuss the game plan on the course. We'll talk about the drilling operations in some details. This is a typical image of driller console. Some monitors, for example, this weight indicators, hook load, and so on. This monitor of drilling parameters, example. For example, ROB, rate of penetration, also weight on bit, torque, also hook load, for example, and standby pressure. This sensors, especially in the mud logging sensors, and we'll talk about the mud logging sensors in the next section, inshallah. The casing after drilling is finished, then they start casing the hole, contain the formation fluids, and control their flow. Also to prevent the upper weaker zones and prevent caving of the hole. Okay, for the casing, sorry for the internet interruption. For the casing types, they designed the section depth based on the geological information. For example, they designed conductor depth up to below the unconsolidated formation. So the casing of the conductor casing is here. Then surface casing just below the freshwater. Then intermediate just on the top of the seed rock or cap rock. Then the production or liner just starts from uh, the top of reservoir up to the end of oil zone near to oil water contact. The difference between production casing and liner, that production casing starts from the bottom up to the surface. But for liner hanger, they hang the casing uh, to the intermediate casing, just a few meters overlap. This example of casing, we'll talk about the grades of casing and the casing program and the accessories. For example, centralizers, float shoe, and uh, float cooler. Cementing operation, it's a process of mixing and displacing a cement slurry down the casing up to the annular behind the casing. Uh, then it allowed to set, uh, thus bonding the casing to the formation. The most important function of the casing is to establish zonal isolation to prevent fluid communication between different production zones. Also, to prevent corrosion of the casing and um, to support the casing. There are a lot of types of cement, but those are the most known and most used types: conventional cement and lightweight cement, also thermal cement. Each one should be used based on the conditions of the formations and the well. This is the example of cement units. We'll talk about cement unit and different elements and components of cement, for example, silos and mixed batcher, and we'll talk about compressors. We'll see some real pictures about these components. They use some additives to modify the properties of cement. For example, they use lightweight or heavyweight additives to reduce or increase slurry density as per the cement program. Also, they use retarders to increase thickening time and retard setting. And accelerators, they use it for to reduce weight on cement time and to increase air strength. Also, they use fluid loss additives to reduce water loss and help sensitive formations and to help prevent premature dehydration. And we'll talk about each type of additives. The final operation, the rig side, is well testing operations. The major purpose of well testing is to determine the ability of the formation to produce fluids. Also to answer those questions, what is the fluid type and how much it can be produced, also what are reservoir uh, characteristics. So well testing operation is cross-checking of the previous interpretations and uh, evaluation work. The second part is the map logging operations, and we'll go through it in maybe 10 minutes. Um, there are two main responsibilities of map logging, or we can say two main scope of map logging: formation evaluation and drilling monitoring. The formation evaluation related to evaluate the formation and interpret the cuttings, make a description, as we will see. And the second part is related to monitor the drilling operations using sensors, and we will see some examples of each one. The duties and responsibilities of map logging crew, for example, sample capture, collects and prepare cutting samples as per sampling program. Also assist map loggers in monitoring the well and maintaining the equipment. This is a typical image of sample capture, taking and cutting sample from shell shaker. Map logger um, describes samples and analyze cuttings and make interpretation. Also evaluate hydrocarbon shows, oil and gas. Identifies formation tops. Also checking lag time every time, and then as per the program. Also determines zone of interest, especially sweet zone of oil uh, saturation, and we'll see about how to evaluate oil shows. Also prepares and updates master logs. Uh, also picking and determines the casing and core points. Also provides reports, for example, daily geological reports and final well report after finishing the drilling operations. Pore pressure engineer, its main responsibility is to predict pore pressure, also estimates pore pressure uh, during the drilling operations, build model for pore pressure that re-drilling, then update and cross-check the model during the drilling using the new data and monitor the well stability during the drilling operations and prepare reports for well site geologist and drilling supervisor. And we'll talk about different gradients, and we'll see how to determine, for example, each casing section based on trends of these gradients. The most important and the top position at the map logging is the data engineer, team leader. He's responsible for acquisition and presentation of real data time to the client. His main responsibility is drilling operations monitoring. So he monitors and interprets real-time data using sensors and gas system after conducting the required calibrations. Also, preparation and presentation of daily reports, mainly operational reports and um, the calculation of non-productive time, as we'll see inshallah in the course. Uh, he should attend most of operations and jobs uh, that conducted on the rig side. As example of team leader, usually he is very busy staring at screens, answering phone calls, to communicate with drill supervisor and well-site geologist. So mod logging unit serves as uh, information center. We'll see inshallah at the end of this session the interaction between mod logging and other uh, disciplines. Is the safety equipment in the mod logging. For example, this is emergency shutdown. This is the 30-minute breathing apparatus. This is SCABA, self-contained breathing apparatus, especially during hydrogen sulfide break. It's the wind soak, and those are different types of extinguishers, fire extinguishers. This ground cable, in case of area of rain, heavy rains, and thunders. Also during the normal operations, they used ground cable. This is a part of the formation evaluation process. Usually, uh, this part is conducted by mud logger. They use binocular microscope and fluoroscope to test the, for example, lithology and hydrocarbon content. For example, um, at first he gives percentage of each um, components. For example, how the percentage of sand, silt, and clay on the sample. Then under a microscope, he describes each part of them. For example, sand describes grain size, grain shape, hardness, as we will see inshallah in the course. We'll go in depth about mainly clastic uh, rock. And at the end, he updates the master log using drain parameters information and gas information. The final output of this part is the master log, which contains information about formations um, and brief description of each section, also about hydrocarbon shows, for example, about gas shows and oil shows, and drill parameters, for example, rate of penetration and weight of bit. Inshallah, on the course, we will go in much details about how to describe samples and make the proper interpretation using this data. It's the oil shows evaluation steps. Step one is to check oil stain under microscope, then determine percentage of oil stain and the color. Step two, to check the fluorescence distribution using fluoroscope or UV box, um, the percentage and type of distribution, and also the color and brightness. Step three is solvent cut fluorescence by adding solvents, for example, chloroform or acetone. They describes percentage of uh, cut fluorescence, then the uh, reaction speed, then reaction type, and the reaction color. Uh, these three steps are essential in evaluation. Then after finishing these three steps, they give number, for example, one for weak oil shows, two for poor oil shows, three weak fair and 3 for good oil shows, as we'll see inshallah in master logs in the course, because we don't have much time to go in details, just 1 minute left. This is an example of daily geological report. Inshallah, we'll have some time during the course to discuss the elements of daily geological report. But in brief, it contains information about the well, including um, the section, different sections, and spot in date, and the meterage, 24 hours meterage, the progress, also average rate of filtration. Then it contains lithological description of the intervals, a brief description of intervals, then about the gas shows, including total gas, ground gas, and components, and also remarks about carbon dioxide and hydrogen sulfide, because both have um, great concerns. For example, carbon dioxide, either it's if it is biogenic or thermogenic gas, it has an impact on the quality of oil. Hydrogen sulfide, the toxic gas. So if they detected minor concentration of hydrogen sulfide, it must be written on the report. Then the part of oil shows, fluorescence, for example, interval of the oil shows, the lithology, the color and distribution of the fluorescence, also intensity, and the cut or solvent fluorescence, also oil stain and residual oil. This part um, related to formation tops, the prognosis depth, and the actual tops based on the sample. Then uh, some note about the current operation and the next operations, and brief summary about the operations in the 24-hour. Um, then the remarks about lag time check and the details of lag time, for example, theoretical time and actual time, and the caving, which um, a quick evaluation for the conditions of the hole. Also, gas line check, for example, and uh, signature of personnel who prepared and received the reports. This like a record for the life of the well, including the drilling operations and the formations, for future references and for discussing this issue on offsite at the office, for example, for the client company and the government. Then the part of pore pressure engineer is evaluate abnormal pressure, because abnormal pressure causes incidents, for example, kicks and uh, blowouts. So pore pressure engineer continuously uh, monitor the pressure, pore pressure data, and notifies drilling supervisor and wellsite geologist about any abnormal uh, pressure zones. They have model of pore pressure re-drilling, then using the current information to update this model to evaluate and detect the abnormal pressure during drilling operations to avoid any incidents and safety problem. Then after drilling, they conduct post-drilling evaluation for the data using, for example, data from well testing, wireline logging, like pressure points, and the well testing data to build a model for the next well, because this well will be the offset well for the next well. The second part is drilling operations monitoring, which is the main responsibility of data engineer or team leader. They monitors drilling parameters to evaluate the performance of the ring operations. Also, it makes the necessary communication between different parts. For example, the ring supervisor and driller. Also, data engineer estimates the non-productive time and produces uh, operations time sheet. In this part, we'll talk in depth about the drilling parameters that monitored by mud logging unit sensors. For example, this block height sensor, also known as depth sensor. This sensor is attached to or installed at draw work. Inshallah, in the course, we'll talk about the calibration of this sensor and how it monitor and records the depth, then the rate of penetration data is interpreted from the block height. We'll talk, inshallah, about the different types of sensors. For example, the encoder and digital sensors counter. It's a close look of the sensor. This image of a position computer of the drilling operations. It reflects the instantaneous parameters. For example, pumps, different pumps, stroke per minute in each pump, active mud tanks, how much barrels, also flow out percentage, the depth, weight on bit, and different parameters. These are instantaneous parameters. We'll talk, inshallah, about the software and hardware of the monitoring system. This, for example, the drawer sends current to the different sensors, either on the road floor or on mud tanks. Then the sensor sends back signals that interpreted and displayed on the screen. Inshallah, we'll talk about each type of sensors, about the calibration and how to interpret this data. Okay. Mud logging unit serves as information center, for example, between logging while drilling or directional drilling crew and mud logging crew. Mud logging unit provides information about depth, rate of penetration data, and LWD crew in return provides information about survey and logging data. Also, Wellsite geologist mud logging unit provides information about lithology, oil and gas shows, drilling parameters and mud parameters and gas data. This is the typical screen of Wellsite geologists. Also for wireline logging crew, mud logging unit provides information as a master log, including the formation tops and the formation and description of each section. And the wireline logging crew provides information about logging data. With cementing engineers, mud logging unit provides information about pump rate and pressure, and cement engineer provides information about displacement volumes to the mud logging unit. Between the driller and mud logging unit, the monitor of the driller consists of drilling parameters and gas parameters and mud parameters, so he can detect and evaluate any change in trends. Then between drilling supervisor and the mud logging units provides monitor on the drilling supervisor office consists of drain parameters and mud parameters. So it facilitates operations monitoring process between the mud engineering and mud logging unit. Mud logging units provide information about mud volumes, total, for example, PVT, bit volume total, and about the mud density using sensors on the temperature in and out. And mud engineers provides information about uh, mud analysis and mud test, and also report, a copy of mud report to the mud logging unit, and also offsite the real-time uh, operations monitoring between the office and the mud logging unit on the rig side. Inshallah, we'll talk more about the advances and innovations of the mud logging. But for example, they use a high resolution digital microscope in description. Also, X-ray fluorescence, XRF, and XRD um, equip, uh, equipment to facilitate the interpretation and conduct quantitative analysis of the minerals present in the cutting sample. Also, pyrolysis and gas chromatograph mass spectroscopy. They installed instrument on the rig side, on the mud logging unit, to evaluate the maturity of hydrocarbon in the cuttings, and quick analysis at the rig side about the source rock and the quality of hydrocarbons. Okay, time for question.